So what could possibly justify spending like $915 on a single video cable? I mean, most of us just grab whatever black cord is stuffed in a drawer somewhere,
Yeah,
right?
exactly. It sounds completely absurd at first glance.
Right. But today's deep dive is actually looking at a spec sheet from HDTV Supply. It's for the DVIGear DVI-2880-AOC DisplayPort cable.
Quite a mouthful, but a very specific piece of tech.
For sure. And our mission today is really figuring out why you'd pay a near $1,000 MSRP for a cord that, well, secretly houses a highly localized laser network.
It's wild. But the context here is extreme distance, you know? I mean, we're looking at an 80-meter run. That is over 262 feet of cable.
Wow, over 260 feet.
Yeah, and pushing a 32.4 gigabit per second aggregate data rate that far is, it's an entirely different physics problem than just hooking up a desktop monitor.
Well, because that massive bandwidth has to handle 8K resolution at 30 hertz. Or, 4K at 120 hertz.
Exactly, plus 32 channels of uncompressed audio on top of that.
Right, it's just this absolute fire hose of data.
Yeah.
Sending that much electrical data over 260 feet of standard copper is like trying to slide a puck across a mile of unpolished ice.
That is a great analogy, actually. The physical friction, well, the electrical resistance in this case, eventually just eats the current.
Yeah, the signal just drops off entirely or, turns into a flickering mess. Which brings us to the AOC part of the name, right?
Right, Active Optical Cable. So to completely bypass that electrical friction, this hybrid cable converts the data into light.
Wait, light?
Seriously.
Yeah, it uses 4 glass optical fibers alongside 6 copper members. But it's not just a basic fiber line. It actually uses 850 nanometer multi-mode lasers to shoot the data down the line.
Okay, and the multi-mode aspect is really crucial there because it allows multiple light paths or modes to travel down the same fiber simultaneously.
Exactly. By bouncing them at slightly different angles, it massively increases the data density.
So you aren't just buying a display cable, you're essentially installing an ultra-fast fiber optic backbone. Pretty much. But converting electrical signals to light at that volume usually requires, serious hardware.
I would think so. Spawning 4 independent laser streams over 80 meters brings up a massive engineering hurdle.
Right, like where is this cable pulling its power from if it doesn't have a massive wall adapter?
See, that's where I was looking closely at the specs. You'd totally assume a setup like this needs a bulky external power supply.
Most people do assume that, yeah.
But surprisingly, it pulls less than half a watt, 0.43 watts to be exact, directly from the source device's DisplayPort.
It just sips power to run those lasers, and that ultra-low power draw solves half the safety equation inside a commercial building.
Oh, and the other half is the physical jacket, right?
Yeah.
Because the specs list this as plenum rated, specifically UL-CMP-OF.
Right, because for a cable running through a commercial building's drop ceilings or HVAC spaces, standard PVC jackets are an absolute non-starter.
Oh yeah, if those catch fire, they burn rapidly and emit this toxic black smoke that just spreads through the ventilation.
Which is incredibly dangerous. So this plenum rating means the jacket uses a specialized fluoropolymer. It physically resists combustion and basically acts as a localized fire break right inside the walls.
That is wild. And add the fact that the core data transmission is optical, and your EMI and RFI issues just disappear completely.
Zero interference. You could run this 260-foot line directly parallel to an MRI machine, or like an industrial transformer.
Or a bundle of high-voltage power lines.
Yep, and that 8K video won't drop a single frame.
Fishing a heavy-duty cable like that through tight drywall still sounds like a massive headache, though.
You'd think so, but the physical design actually accounts for the installation process. It uses detachable mini DisplayPort connectors.
Oh, so they have a tiny physical footprint.
Yep, allowing you to easily snake the bare wire through the tight conduits, and then you just snap them into full-size locking docks at the very end.
It's just a perfect example of the invisible infrastructure required to make modern high-resolution displays function reliably in hostile physical environments.
It really does put the physical demands of our digital expectations into stark relief.
Totally. And hey, even if you aren't currently building a professional video matrix in your house, it fundamentally changes how you look at what's running behind the drywall.
Definitely. Though if you are building one, the source notes you can actually use the code 10% off at checkout.
Oh, nice. Well, let's leave you with this thought to ponder. If it requires actual glass fibers, localized multi-mode lasers, fluoropolymer fire breaks, and $915 just to reliably push a single video signal 80 meters across one building without a flicker.
Right.
Just imagine the unfathomable physical engineering required to sustain the thousands of miles of underwater cables powering the global internet you are using right now.